government. They do names, symbols, and units for chemistry elements, and more than 1,200 chemists are involved. They was formed in 1919 by scientists. The importance of having the rules defined is because we can differentiate and classify hydrocarbons and make the explanation easier.
Hydrocarbons are compounds that only has carbon and hydrogen, are divided into saturated and unsaturated. Saturated, alkanes, only single bond. Unsaturated, alkenes, double bond. Alkynes, triple bond. And aromatics, pentane ring.
Alkanes are the simplest organic molecules consisting of only carbons and hydrogen and with only single bonds within their carbon atoms. The steps to name an alkane are: number 1. Identify the parent change or the longest change. Number 2. Identify all the substituents. Number 3. Number the carbons of the parent change from the end that gives the substituent the lower number. Number 4. If the same substituent occurs more than once, the number of times that the substituents group occurs is indicated by a prefix D, 3, tetra, etc. And number 5. If there are 2 or more different substituents, they are listed in alphabetical order, and we ignore the prefix. At the end, we name the parent change with the prefix plus "ane". We need to identify the parent change. That is this one. This one is not our parent change. Then we need to count the carbons to the lowest number. 1, 2, 3, 4, 5, 6, 7, and 8. Then we need to identify our substituents. Is a methyl, an ethyl, 2 methyl, and 1 ethyl. The result of the name of the alkane are 4 ethyl, 2 4 D methyl octane. 4 ethyl represent this substituent in the carbon 4. 2 4 represent the ethyl, the dimethyl in the number 2 and carbon 4. 2 4 dimethyl, dimethyl because we have 2 methyl in different carbons, and octane because the parent change have 8 carbons.
The general formula is number of carbons and the number of hydrogens. Their hybridization is sp2. And for naming alkene, we have to count the number of carbon atoms in the longest chain. For example, we have 1, 2, 3, 4, 5, 6, 7, but we have another chain. We have 1, 2, 3, 4, 5, 6, 7, 8. This is the longest chain. And then we have to count from the nearest carbon to the bond. We have 1, 2, 3, 4, 5, 6, 7, 8. And then we have to indicate the alkyl groups. Here we have methyl. And here we have another methyl. Another methyl. And then we have to indicate where is each alkyl group. For example, we have here, there is in the second carbon, there are 2 methyls, so we have to put 2, 2, and this one that is in the 6th carbon. We have to use a prefix that is 3, because there are 3 times the alkyl group, and then since 3, methyl. Here we have to use a difference to separate numbers from letters, and then we have to indicate where is the bond, the double bond. Here we have 1, 2, and 3. In the number 3 carbon, in the carbon number 3, we have to put 3. And this is an octane because we have 8 carbons in the longer chain. But this is an alkene, and the alkene ends with "in", and so it's octene. This is our
Alkynes. Alkynes are identified as organic chemical compounds that have triple bond in their chemical structure. They are organic compounds that are used in many industrial applications. In this lesson, we will learn all about alkynes. The general formula of alkynes is CnH2n, and the steps to name alkynes are almost the same. The only differences are: the largest chain must include the double bond. Number must start ending to the closest triple bond. Indicate the location of the triple bond and changing the termination R to "ane".
And for this alkyne, we have to use the same rules as the alkenes. We have to number the number of carbons in the longest chain. For example, we have this that is 1, 2, 3, 4, 5, 6. Number of carbons in the longest chain. So we have to indicate the longest chain, and we have to number them. And then the alkyl groups. This is a methyl. And then also we have to indicate where is the triple bond. But first the alkyl groups. In the number 4 carbon we have a methyl, so we have to put 4-methyl. Then hyphen. We have to indicate where is the triple bond. In this case is 2, and we have that is 6 carbons, so we have to put 2-X, and because it's an alkyne,
Aromatic compounds, originally named because of their fragrant properties, are unsaturated hydrocarbon ring structures that exhibit special properties, including unusual stability due to their aromaticity. They are often represented as resonance structures containing single and double bonds. However, the bonding is stronger than expected for a conjugated structure, and it is more accurately depicted as delocalized electron density shared between all the atoms in the ring. When we only have one substituent, the only thing we should do is add the substituent name and the whole benzene table. Substituent plus benzene. Examples of these are chlorobenzene, nitrobenzene, and methylbenzene. When we have two substituents, we have two options: use number, the lowest, or use prefixes: ortho for place 1 and 2, meta 1 and 3, and para 1 and 4. Now we're going to see one example. First, we highlight the bromo and the chloro. The name of this compound will be 1-bromo-4-chlorobenzene, and with prefix will be p-bromochlorobenzene.
My personal conclusion is that hydrocarbons are essential in our life, and almost all the things that we have are made of it. Thanks to organic chemistry, we know where they are made. For example, the gasoline, for transportation, the kerosene, for the airplanes, the plastics are made of polymers, and all of those things are thanks to the organic chemistry. Hydrocarbons are the basic compounds of organic chemistry that contain only hydrogen and carbon. Hydrocarbons are an important source of energy generation for industries, for our house, and for the development of our daily life. Hydrocarbons are a source of energy for the modern world, and also a resource for
Well, in my conclusion, I can say that I think that the IUPAC system is a very good way to name compounds like alkenes, alkanes, and aromatics because it gives a very good name into the compounds.
Well, I think that the UPAC rules give us an easy way to name different organic compounds, and also it gives us an easy way to learn about the organic chemistry.
My conclusion is that this topic is very important because we need to know how to name hydrocarbons and what is their function.
In my personal conclusion, I think that hydrocarbons are very important because they are the building blocks of everything that define the modern society. Also, we use hydrocarbons for fuel. Thank you!